All right.
Cool.
Hi, everyone. Thanks for coming along tonight. Great to see a full room. After I've done my talk, if you want to play around with three of the demos I'm going to do tonight, I've put them into this sort of public repo. So if you want to have a play around in the background to sort of download the code and get ready for that, there's the details there. But thanks very much to Python Glasgow for having me along tonight, for David and Aaron who kindly met me here earlier and got all set up for tonight. Let's keep the thing interactive, so if you want to just interrupt with any questions as I go through, I'll try and answer the questions. I might defer them. So here we go. So we're talking about no compromise data apps. First, a little bit about me. My name is Barry Smart. I started my career about 30 years ago as a graduate software engineer. I spent a bit of time in the water industry, and then I spent my formative years actually at Scottish Power as chief architect for their energy trading business. And then in 2011, I moved into financial services, and I got promoted to CTO. And then after a hackathon, this picture here is me involved in this hackathon, I had a bit of an epiphany. I just rediscovered coding, I rediscovered data, so I decided to take a year out, and I went back to Strathclyde University, and I studied a master's in artificial intelligence. And then after I finished my master's, I joined Engine, where I'm Director of Data and AI. Engine are a small technology consultancy. We're fully remote, based here in the UK, and we've got clients all around the world. And we like to say that we help small teams achieve big things. And we specialize in cloud-native application development and cloud-native data analytics and AI projects for our clients. I'm head of the Scottish operation, which means I'm the only person in Engine based in Scotland. I live in Falkirk, just a train line away. The rest of the team are spread south of the border. A little bit more about me. I love mountain biking. That's one of the things I do when I'm not working. So this is me at Bo'ness. And the route I did that day took me from my home in Falkirk along what's called the John Muir Way into the centre of Edinburgh. It's a beautiful trail, most of it's off-road. But I came across something utterly fascinating in Bo'ness. This small cottage, very hidden away, you'd hardly notice it, but it's where James Watt conducted his early research in secret to develop the steam engine. You can think about the impact that the steam engine had on modern society. It really gave birth to the industrial age. And we're kind of leaving the industrial age and we're entering a new digital age, which is fueled rather than by huge amounts of physical power. That's what the steam engine gave us. It's giving us huge amounts of thinking power. And that's moving at an incredible pace at the moment with generative AI and everything that's coming at us at 1,000 miles an hour at the moment. So it's a really exciting time to be a data professional and to be working with clients who are, investing in data and AI projects. So, no compromise data apps. So what I want to talk about is those situations where, how many people work with Power BI in the room? A few hands going up. Or similar tools like, what's the other one? Tableau, for example. Yeah, okay. So what happens with these tools is sometimes you feel what the user's asking you to do, you feel like you're fighting against the tool to try and deliver what they're looking for. And that's where data apps come in. So I'm separating traditional reporting tools like Power BI, Tableau from data apps. Both are interactive, both are data-driven generally, but what's interesting is with reporting tools, the interactivity is driven by the data model. So in Power BI, you put a lot of effort into designing the semantic model, the star schema, you've got your fact tables, your dimension tables, you link all of that up, you lay your measures on top, and that drives the filtering and the drill through functionality that people have grown accustomed to in these kind of tools. Whereas on a data app, the interactivity is driven by an algorithm. As a user, you interact with the inputs, the algorithm runs, and it generates the outputs. And you can go round and round that loop as many times as you want. Another interesting thing that separates these two different experiences is really the way that you develop. So with a tool like Power BI, it's very much no code, low code. You're sort of dragging and dropping, building the dashboards with your mouse. Whereas with data apps, it's very much a code-first approach. So if you're a Python developer, it feels a bit more natural to be working in that kind of environment. The other thing that I tend to find with tools like Power BI is they're great to get going. You can drag a bar chart on, a line chart on, or a pie chart on, and it looks great. But if your clients often say, can you just move this, can you put the legend here, or can you format the axis in this way? And you tend to hit limitations because you're configuring, you're not coding. Whereas with data apps, you can bring in your favorite charting library, and you can really fine-tune how the charts look and feel. So you can get sort of data science, scientific quality charts and graphs into your experience if you're using a data app. And I think because reporting tools are very much about loading data into a data model and then exploring that data, they're much more used for descriptive analytics. So kind of looking backwards. So looking at your financial performance over the last 12 months, for example, you're kind of doing descriptive analytics. Whereas data apps, because you can integrate with models like machine learning models that you might have trained to do predictive analytics, you can actually use data apps to be looking forward as well, if you can integrate machine learning into that experience. So the data app I'm going to focus on today framework is Streamlit. I'm not affiliated at all with Streamlit. It's an open source project. We use it in certain use cases with our clients, and we've been getting a lot of value from it. And we just want to share our experiences and hopefully inspire some of you to have a play with Streamlit as well. So Streamlit was created back in 2018 by a team that spun out of Google. The project went open source in 2019, and then it grew over the next couple of years. Really good growth. It got over 2 million downloads and active users of the technology. And then, due to its success, it was acquired by Snowflake in 2022. Any Snowflake users in the room? Yeah, okay. So the good news is Snowflake is a cloud scale, elastic scale SQL database in the cloud. Basically, you can't fill it up. You can have as much data as you want in Snowflake, and you'll never fill it up, and you've got a SQL environment to query the data. There's a big organization, a big player in the data platform space. But the good news is they committed to keeping Streamlit open source, but they've integrated it into the product. So what it means is if you've got a Snowflake subscription, you can create a Streamlit app and host it on your Snowflake environment and share that Streamlit app with other users in your organization that can connect to Snowflake. So the good news is it's been acquired, but it remains you can use it without Snowflake as well, as I'll show you later in the presentation. So Streamlit is a Python package, really simple. Pip install or UV add or whatever your package management tool is, and you've got it in your Python environment. No servers to install, no infrastructure to set up for the development phase anyway. And it's really easy to use. You install it, you write your code in your favorite code editor, and then you can run your project locally simply by issuing the command Streamlit, run, and then the name of your Python script. And what we really get a lot of value out of this fast inner dev loop. So as you're writing the code, the app will come to life as you're editing your code. So it's really great for prototyping and just getting that fast feedback loop as you're developing. The documentation's fantastic. I'll show you that in a second. And then, yeah, it's just a case of deploying it. So I talked about Snowflake. You can deploy it onto Snowflake if you've got a Snowflake platform that you're acquiring on the cloud. You can publish your work to the public Streamlit community platform, but that means you're sharing your Streamlit app and your data with everyone globally. They can discover it and use it. So if you've got some of the projects I'm sharing on the repo, They're all over open source data, so that would be a good place to try. Just if you've built a Streamlit app you're proud of and you want to share it with the rest of the world, you can publish it there for free. And then one mechanism I'll show you tonight is that if you've got a cloud platform like Azure or AWS, you can package up your Streamlit app using as a Docker container and just deploy it onto a service like Azure Container Apps, and it's pretty straightforward to do that. So one other thing I've kind of injected into the talk tonight, because it was something I was talking about last week at SQL Bits, is the concept of distributed compute. Is anyone in the room using Databricks or any of these kind of Spark-based technologies, Synapse, Fabric? Have you heard of any of these platforms? So they all leverage Apache Spark. And the subject of this kind of slight divergence is, where the talk I did at SQL Bits last week was basically trying to change people's minds about using Spark. It's a distributed platform. It can scale up to massive scale, but there's new tools emerging in the market that actually are faster, cheaper, more agile to use. But Spark has had massive success. It's embedded in all of these sort of major cloud platforms that big enterprises tend to use when they've got data teams and data projects. And yeah, so what I'm saying is that in the majority of cases now, we're finding, certainly with clients, using Spark's like taking a big dirty juggernaut down to the Tesco's to pick up your grocery when there's faster, more agile, cheaper, cleaner solutions out there. But I'm not dissing Spark. It's an amazing technology. It dates back to the early 2000s. Google came up with the idea because they were sitting on top of data that was growing at internet scale at that point, and they got to the point where they couldn't fit all of their data onto a single server. So the solution was to separate storage from compute, and then to distribute that storage of the data and the compute across lots of commodity servers. So rather than trying to grow one big box to try and manage all this data, they spread it across many servers. Yahoo and the open source community took those ideas and they developed Hadoop, which became very popular for big data processing. And then another layer of innovation on top of Hadoop produced Spark. And the creatives of Spark open source Spark through the Apache Foundation in about 2014. But they then went on to commercialize Spark as Databricks. Has everyone heard of Databricks? Massive platform. But also Microsoft have built Spark into Synapse and more recently Fabric, and also Amazon used Spark as a core distributed compute engine. So that the history of Spark's about 20 years old in the making. But over the last 5 years, something much more significant, or something significant's been happening, which Hannes Mullison, who is a professor of data engineering and co-founder of DuckDB, calls the approaching data singularity. And what he's talking about is that over that time period, thanks to Moore's law, the processing capacity of a single node, like your laptop here, has continued to increase at an exponential rate. Whilst he argues that the size of useful data sets has grown at a linear rate. He argues that useful data is really bounded by human capacity. And what he's talking about is this crossing point where a single node will be capable of processing 99% of useful data. Now, for everything above that line, we've relied on technologies like Spark. They scale out across many machines. You deploy the jobs across clusters. And traditionally, for smaller data, we've been able to use things like pandas, okay? But what's interesting is pandas is as old as Spark. It's about 20 years old, and it's not geared up to take advantage of modern processing capacity technology. And there's some new kids on the block. There's many examples, but the two I want to focus on tonight are polars and singularity. But we're certainly finding that 80% of the workloads we're working with for clients fit on a single node if you use these technologies. And this is backed up by research. AWS published some of their query workloads for their Redshift platform, and follow-on analysis of that showed that 90% plus of the queries that were being run on that platform didn't actually need big data infrastructure to run. So, the typical workloads we're working with for clients are in this kind of range, 100,000 rows up to, say, 100 million rows. And those kind of workloads will sit comfortably on Polars and DuckDB. So I would argue that's your kind of 80% of your workloads fit here. And then if you happen to be working with bigger data sets, then you can use Spark for that process. So why do we care about this? Well, if you're running workloads on a single node, you can develop locally. You don't have to be developing in the cloud, which can feel a bit slow and clunky because you're waiting for clusters to spin up. It's cheaper because you're not running a cluster. It's faster to develop. That inner dev loop I was talking about earlier is preserved. And to be blunt, you're not just saving money, you're saving the environment. Spinning up I've done it, spun up a Spark cluster to process something that's come out of a spreadsheet, right? It's crazy. So these technologies are amazing. They're fully open source. Let's tell you a wee bit more about those. So DuckDB, you can see the sort of strap line there, but both are open source. DuckDB is implemented in C++, and Polars is in Rust. So these are low-level languages that are able to, they're kind of silicon-level languages. They're able to take advantage of cores and all the sort of latest developments that we see in CPUs. They come as Python packages with 0 dependencies, and they're both in-process analytics. So they run inside your Python process. You don't have to install a server or set up any other infrastructure. Wherever you're running Python, you can use these technologies. And they're designed to take full advantage of the hardware that they're running on. So I've got a nice, powerful laptop here, so these technologies just fly when they're running on my laptop. There's some differences. So DuckDB, as the name might suggest, has got a SQL API. So if you like writing SQL, it's perfect for that kind of working pattern. Polars is a data frame API. So you're used to working with pandas. It's kind of similar to pandas. But where Polars differs from pandas and also DuckDB is they have a lazy evaluation model. So they don't execute your query until it's needed. So you can build up a complex query, and when you do need to materialize your query, it will optimize it and then generate the result. So that alone can save a lot of processing power and CPU. As DuckDB, again, suggests, it supports sort of database concepts. You can create databases in memory or on disk, and it supports concepts like schemas and ACID transactions. Polars is data frames, so it doesn't have any of that. But more recently, Polars has also offered GPU acceleration, so you can take advantage of your GPUs as well with Polars. So the reason I mention these is that I'm using them in the demos tonight, and it means that it almost feels like a perfect marriage of Streamlit running on my machine or in a small Docker container with these as the back-end engine serving up the data into your Streamlit app. So that's why I wanted to sort of talk about it a little bit more. Has anyone in the room tried DuckDB or Polars? Yeah, cool. Another thing they share is there's interoperability here. So you'll see quite a bit tonight. I'll do quite a bit of the work in DuckDB, and then when I need to generate a chart or something, I'll export to Polars and use a charting library to visualize the data. And that's enabled through Apache Arrow. So at runtime, because they both support the Apache Arrow standard for in-memory data storage, it means that there's no overhead, I/O overhead, and sort of pushing data from one tool into the next. They can basically share the data in memory. But the same interoperability is available with Spark. So you might have you can mix and match these technologies, I think, is the interesting thing. And then at the persistence layer, all of these technologies support data lake formats like Delta. So you can persist the data to your data lake. So you might be writing with Polars, and then you could be reading with DuckDB. I've got all these different patterns to operate under as well. Right, so that's enough about those technologies. I just thought that would be interesting to inject into the talk. So what I'm going to do now is a bit of a demo. This is my demo environment. I'm using my amazing Windows Surface Studio laptop here. And then, because I like to keep all my demos containerized, I'm using Visual Studio Code dev containers. So that requires Docker and Windows Subsystem for Linux to create the dev containers. And then in each dev container, I keep it really simple. It's just a vanilla base Linux image. And then I use UV to install Python and all the packages I need. So it keeps each one really light. So if you look at that repo, you'll see that's the way I've been working to build the demos. So let's head over to VS Code. Has anyone got any questions at this stage? Are you ready to see more? Okay. So here is, I'm going to zoom in a wee bit. How's that? Can you see at the back?
Yeah.
Cool. So this is my first Streamlit app. Isn't it amazing? Let's start building our Streamlit app. So Streamlit's already installed in this environment. I've done pip install Streamlit or the equivalent. So I can now import it into my Python script. And the convention is to use the alias of st for Streamlit, just to keep the code succinct. And then it's a case of building my app. So I want to put a title at the top of my app. So I'm going to use Hello World there. And now it's a case of running my app. Don't know why it takes a wee while to do this. So you can see there, I've not pressed enter yet. So because I'm running inside UV, I've got UV run. But then the key thing is at the command line, it's Streamlit run and then the name of the Python script, which you can see above. Let's press enter. There we go. So what it's done is it's fired up the app locally on my machine. You can see the URL here is localhost, and it's rendered my application. No round of applause? Oh, Thank you. Sorry, a question?
Yeah, is that in the browser? Can you get like a separate window?
Yeah, so I can. So that's just launched in my local browser. So what I can do is just dock that to the side, put my Streamlit app there side by side, close all this down. So you can see it's opened in this URL here. Okay, and we can keep going. Let's keep developing our app.
Do you have the option not to be in the browser?
I could just keep developing and not launch the app. The only way to consume Streamlit apps is through the web browser. It's a web interface. Yeah, it doesn't. That's the only way you can access them. Good question. Okay, so I'm now going to add some content. So st.write, and then anything inside this method, it will render it inside the application. So when I added this code, it detected there was a change. And it then gives me these two options. So I can say rerun, one-time rerun, or I can say always rerun. So as it detects changes, it will render those changes in the web browser. So I'll choose that option. And you can see there it's added that content. So I could continue to do, oh, this is where, there we go. So as I change the content there, it's rendering the app on the right-hand side. So this is this really fast inner dev loop I was talking about earlier. And then we can do other things like add images, or let's add the, I think I've got the, I think it's,
The live code demonstration strikes again.
oh, I don't know what I've done there. Hang on a second. Let's get back to where we were. So I'm using a tool called Demo Time for the demos. It's really good. So if I do get myself into trouble, I can reset, start my presentation again. I've totally broken it. That's what I get for going off.
I was going to be impressed there if I seen the Python skeleton and the Python master.
Yeah. No, I've totally broken it. Right. Anyway, you got the idea. So that's the basic Hello World app. Okay. That's the rule there is don't go off script.
The live code demonstrations.
Yeah. Just to prove it's a live code demonstration.
Yeah.
So let me just step through that. And we'll get onto this in a second. Right, okay, so...
So can I ask another thing?
Yeah, go for it. Just...
You had a link in the text.
Yeah.
Is that done with Markdown or is it done so much?
Yeah, I use Markdown for that. So let's try and get back to that. Let's try and get it working again. So I can...
I've lost the...
You lost a link.
Oh, there you go. That's okay. We're all right. We're good.
We're back. Let's just do that again. Reset. Start presentation. Hello world. So here we go. First, import Streamlit. Add the title. Launch the app. I don't know why it takes a while to... Oops. I've got two spinning. There we go. Hello world. So if I just do that and that, let's get rid of this and that. So yeah, so in here you could see, I'm going to zoom out a wee bit and do that. Yeah, so this is just markdown content here. But I can put in an st.write, I can put a dictionary, a list, and it will render it in quite a pretty way. So it's quite flexible. st.write, it can handle lots of different types of objects, and it will render them inside the app. And then if we keep going, there we go. There's our engine logo added to it. So that's really basic application. Let's move on to something a bit more real world. So the next demo is what I call high fidelity reporting. So that's that case where you feel you can't quite achieve what you're looking for in something like Power BI. You want really fine-grained control over the graphs and visuals. So the scenario here is, imagine you're a data scientist working at the Titanic Museum, and you've got all this amazing data about the passengers on the Titanic. And so they've asked you to build this interactive dashboard in the museum so that visitors to the museum can explore the passengers, who died, what the demographics were. So the demo I'm going to run, this is the kind of setup I've got for all of the apps. So I've got a notebook where I do the initial exploration. So I tend to start in a notebook with the data, inspect the data. But as I add complexity to the notebook, I tend to move the kind of wrangling out into a wrangler class and the charts out into a charting class, so that it just keeps the notebook concise and readable. But the nice thing about doing that is that those same wrangling and charting classes I can then pull into my app at the top there. So in the app folder, I've got my Streamlit app. It'll import these classes, as you'll see, and it keeps the Streamlit app really succinct as well. So as a data scientist, if we head back over to VS Code, let's move on to the next. Oh my God, I don't know where it's gone. Here we go. So this is my Titanic data exploration. So if I just run this cell by cell. So I've got some helper classes here to load the data. And you can see this first cell is going to take about 5 seconds to run. There we go. And that's because I've deliberately built in, I know it's crazy, but I've built in this delay into that loading process because I want to simulate a long-running operation. So for a lot of data apps, you might be calling off to a big database to run a query, or you're running a model when it's doing lots of simulations or running an intensive operation. So you tend to get these sort of long-running operations that you need to deal with. So I'm just sort of simulating that here so we can show how in Streamlit you can deal with long-running operations. Once I've got the data, I then clean it up, and then I get this lovely cleaned up data set. So I've done things like some of the ages and dates of birth are missing. I've cleaned up the data, extracted people's title from their name, you know, done all that kind of stuff. So I've got a nice data set now to explore, and then I can generate these kind of charts. So I can start to look at, in this case, we've got survival status here in red and green, by gender, by age. So there's some quite interesting trends starting to come out of the data that I think would make a nice dashboard for people visiting the museum to interact with. So I've done all the work in the notebook, and I want to turn this into a Streamlit app. So the first thing I can do is I can export from a Jupyter notebook into a Python script. So that's all I've done here. So that you'll recognize, and the cells in the notebook are denoted by this comment with the %% notation. And you can see it's actually VS Code's discovering these as individual cells. So I could kind of interact with this script like a notebook, but I don't want to do that. I want to get rid of those in a second. So the first thing I'm going to do is save this over my Titanic app. So this is my starter for my Streamlit Titanic app. And then what I want to do is get rid of these with the magic of some regex, hopefully. You can see it's found all of those, yeah. So let's just replace those. And I've cleaned up my Python script. So I'm ready now to take what was all the code that was in my Jupyter notebook and turn it into a Streamlit app. So the first thing is, as we did before, import Streamlit as ST. And then I can just step through the code now and adapt it for my Streamlit app. So the first thing I'm honing in on is line 7. That's the title. So st.title, wrap that up in that method. The next thing in the notebook, which is of interest, is this point where I displayed the data frame. So any guesses? st.dataframe, wrap that up in there, and it will display the data frame. And then I've got some markdown content here. So st.markdown, wrap that up in that method. And then there's 3 charts, st.plotlychart, and I do that for these 3 charts that I've got. Job done. I've reached the bottom of my script, and now it's just a case of running my app. Right, that didn't work. 2 seconds. Yeah. There we go. So you see there's a 5-second delay here. The header's being displayed, but you can see the app's waiting, and then all of the other content is displayed in line. So I'm displaying the data frame, the markdown content, and then the 3 charts below it. And the nice thing here is, you know, you get a lot for free with Streamlit. So because I'm using the data frame method to display this data frame, I can expand it, I can sort it. Let's do sort descending. So I can see, you know, the oldest person on the Titanic was 80, the oldest passenger. I can even search the content. So were there any other smarts on the Titanic? Whoops. Oh, there was. Mr. John Montgomery Smart was on the Titanic. He was 56. He was a bit older than me. And, oh dear, he died. Right, okay, so let's skip over that one. So you just get a lot of nice features like that just for free with Streamlit. There's our markdown content. And then our charts as well, you can expand those and you can interact with them and hover over and all that kind of good stuff. So these are really nice, high quality charts that, you know, this kind of chart would be quite hard to produce in Power BI. Box plots aren't very good in Power BI, and this kind of notation on the x-axis, things like that are pretty tricky, if not impossible, in Power BI. So this is why Streamlit sings for these kind of use cases. So we can see interesting things like, you know, all the reverends on the title of reverend, they all died. It kind of makes sense. They would have stayed behind to comfort the people who couldn't get on the lifeboats. Whereas with doctors, there was a 50% survival rate with doctors. Half of them survived. So there's interesting things coming out of the data. But I think we can do better than this. This is okay. So we've done our first version of the app. We've got the content from our notebook into the app. And the thing with Streamlit is when you run the script that I've got here, it renders all the visual components in the order that it finds them in the script, vertically down the page of the Streamlit app. So there's a couple of things we can do just to tidy things up. So the first thing I want to do is that data frame that displays the passengers, I'm going to hide that away. So that's dead easy to do. I can using this sort of st.expander.data frame, I can put that inside an expander object, which by default is closed. So let's go and have a look at that. So if I rerun my app, 5-second delay. So I'm going to fix this in a minute, don't worry. But you can see now my passenger details are hidden away inside this expander. And I can put anything inside an expander, a chart, any content. What else can I do? Let's keep going. So this markdown content, again, what I can do with that is move that into a sidebar over to the side. So if I rerun my app now, so I'm going to take this content here, this exploratory data analysis title, and I've moved it into a sidebar, which is collapsible, which is quite nice. And what else can I do? Yeah, so the next thing I want to do is put some more functionality inside this sidebar. So rather than displaying all three charts in series, I'm going to give the user a picker, a radio button where they can choose which topic they want to explore, women and children, wealth or occupation. And then based on their choice, I can use the topic that's returned and a simple set of if else statements to display the relevant chart. But also, now I can display a bit of an introduction to each of those charts to give it a bit of context. So let's have a look at the impact of that. So rerun. 5-second delay, sorry about this. So now you can see it's just displaying one chart. And then as I interact, oh, I'm getting another 5-second delay. What's going on here? All right, so every time I'm interacting with this chart, I'm getting a 5-second delay because it's going back and loading the data every time. It's not the greatest end user experience, is it? So let's try and fix that now. So what I can do with that is this is the problem child. So this load Titanic data is where I've got that 5-second sleep. Okay, so one technique you can do is simply put a spinner, because it wasn't obvious to the end user what was going on. So this spinner, I'll show you that. So if I now click on something, actually no, I can't do that. Not work. No, I think I have to refresh the app. Yeah, so now I'm getting this spinner. At least it's telling the user there's something going on and they should wait for that to finish. But we can go one step better. We can take this offending long-running operation and wrap it inside another method which is decorated with this cache data operation. So what happens here is Streamlit provides this functionality out of the box. So whatever is returned by this method here, the first time it runs, it caches the data, and then any other time it runs, it just serves the data that's being cached up. So all I need to do is now call that method to populate my Titanic passengers raw data frame that I can use elsewhere in the app. So we flip over now to here. Let's just rerun the whole thing. So we should see a delay while it's caching the data first time, 5 seconds. But now every time I interact, you see it's serving the data up from memory rather than going back and causing that 5-second cost. So there you go. That's one little example end-to-end of how you can convert from Notebook, Jupyter Notebook, which you couldn't share with people in the business or end users. There's no way you can share on Jupyter Notebook, but through a few simple steps, I've now got a web application with insights and data and charts and information in it that I can now share with a wider audience. So it's a great way of taking analysis you've done back office in your data science bubble and sharing it with other users in the organization. Okay. So you can see these are all the sort of Streamlit features I've used there, from basic things like a title, showing a data frame, showing charts, all the way through to caching. So these are just the examples of what I've shown off there. So the next thing that I can show you is I can now take this application and deploy it onto Azure. So the way this works is, sorry, if I go to here, I've got, inside the project, I've got a Docker file which specifies all the things in this project I want to package up inside a Docker container. So you can see here, the key things I want is obviously the Streamlit app, and then the dependencies it has are the low-level dependencies are defined in the pyproject.toml file, which UV will install for me. The data it needs is inside this project because it's a small amount of data. It's a bit cheeky, but the data is sitting inside the project. And the classes that I develop for loading and wrangling the data and charting the data, I'll also need to package these up inside the Docker container. So you can see that's what's going on here. It's copying those 3 folders into the Docker container. It's also copying the pyproject.toml file and the UV lock file. So when it runs UV to install the app in the Docker container, it knows which packages to install. And then I'm basically defining where I want to expose my Streamlit app on the cloud server, and the command I want it to run to launch the app. Hi there. So what I'm going to do is I'm going to try and remember. So there's a Azure Container Apps extension that you can install in VS Code. So this could all be scripted or using Azure CLI or other sort of more DevOps friendly tools. But I just wanted to sort of show you running this. Deploy project from Workspace. I choose where I want to deploy it. I'm pretty sure it's my subscription. So it's going to overwrite an existing deployment. Yeah, let's just keep going. And I'm going to leave that to run in the background, and then we can see the impact of that later on. Okay. All good so far? Ready for another demo? Any questions there? Okay. So the next scenario is moving more into an interactive predictive model and showing how Streamlit can enable those to come to life. So the scenario here is you're a data scientist working at Edinburgh Airport, and the biggest customer complaint is the time they have to wait in a queue to get their passport checked when they've arrived at the airport and they just want to get home after their holiday. So you've been asked to help the passport control manager optimize shift patterns to meet demand. Okay. So what I'm going to show you here is Streamlit is the whole thing, right? It's the whole app. I've got the shift roster, say, in an Excel file. So that defines how many people are on each shift during the day. I can get the real-time flight schedule via an API, so I can see the latest flight patterns and arrivals. And I can put all of that together to model, depending on which flights are landing, arrivals. I can model how many passengers are joining the start of the passport control queue. And then depending on how many officers are on duty, I can then model how fast that queue is emptying. And then I can see that, decide whether there's enough officers on duty, go back, maybe edit the shifts and see a fresh output and play around with it until I optimize the shift pattern. So what I'm trying to do here is minimize costs whilst maximizing customer experience. So, I could I can make customers really happy by putting 1,000 passport control officers on, but that would cost a fortune. So I've got to try and balance those two things. So if we head over to border force shift planning. So again, the kind of standard pattern, start in Jupyter Notebooks. I've thought about the problem here. So I've got the flight schedule. I know when the planes land. I can calculate taxi time to when they arrive at the stand, then model passengers leaving the plane, because you all file off the plane once it lands and docks with the gate. And then they have to walk from the gate to join the queue. Then based on the number of officers who are checking passports, that defines how long they have to wait in the queue before someone becomes available to check their passport. That might take a minute, and then they're done, they've left the queue. So that's the kind of mental model I've built. So basically what I've done is I've got some helper methods here to grab the flight schedule from a public API. So I've got a day's worth of flight arrivals, flight data here for Edinburgh Airport. So for every plane, I know the model of plane, I know the capacity of the plane. So I can actually model every individual passenger who comes off a plane, just give them a GUID and model them arriving in the airport and passing through that process. So here's an example. This is flight U23204. So it's got 159 passengers on it. It lands at 1:45 in the morning, and then taxis to the gate. Then there's a bit of delay while they get the steps onto the gate, and then you can see the first distribution is the passengers leaving the plane, and then the purple distribution is them joining the passport control queue. So I've solved the first part of the problem. I'm modeling passengers joining the queue, and then then I can load the shift pattern, and I can see the net result of all of that is that we've got passengers joining the queue at the bottom. We've got red as the officers on duty, and you can see during this period where there's fewer officers on duty, the queue builds up to the point where there's, nearly 2,000 people in the queue. That doesn't sound very good. It's going to sound like a pretty miserable experience for the passengers. So I've kind of built the end-to-end solution, but I now want to put this into the hands of the team who are managing the shift patterns. So I've turned that into an app. Here it is. So you can see here I've got the flight data loaded. I can look at that. I've got the shift pattern here, and then I can run my simulation. And this is perfect for Streamlit. It's this kind of thing. So it's a long-running operation. It takes a wee while to model the passengers and the queue. And you can see it's replaying what I just showed you in the notebook. There's this period where we clearly need more people on duty. So basically what I can do is I can take 5 people from the night shift when it's quiet. You can see it's very quiet in the night shift. So let's take 5 people off night shift and put those 5 people back on that sort of peak period. Run the simulation. And you can see I've not cost any more. I've just moved 5 people around, but I've reduced the wait time by 70 minutes. That's pretty good. The maximum wait time is now just 20 minutes, and the maximum queue length is now just 613. So I'm getting there. I could keep playing around with the shift patterns, and I can also play around with other assumptions like what's the kind of time bands for taxiing, what's the time bands for disembarkation, what's the flight. How busy are the flights? I'm assuming they're quite busy at the moment, but I could change that as well. It might be an off-peak period. And what's interesting here is every time I change an input to the model, you can see the app's resetting. So I've deliberately designed it this way to allow me to tweak things and maybe let's add another 5 people onto here. So I can play around with all the inputs and then run the simulation. And hopefully we get. So I'm costing a bit more money because I've put some extra people on, but you can now see the queue's down, max queue length is 33 minutes, 33 people, and the maximum wait time is 5 minutes. That's pretty good. We're getting close. So the way that works in the way that works inside the app, let's have a look at that in more detail. So the first thing I used there is I used rather than st.dataframe, I used st.dataEditor, so that creates an editable data frame. So that shift pattern here, this column, you can see the pencil denotes it. I can actively edit this data frame. So you can not just display data frames, you can allow people to edit them, which is quite cool. And then I can also then configure that data frame to define which columns are editable and maybe change the titles of those columns to make them friendlier and add some formatting. So that's how I add the bars, change the titles of the columns to something a bit more friendly. And then the other thing I've done is create these columns, and so I can lay out the content not just top to bottom vertically. That's how I managed to create these columns to show these widgets all across the 3 columns. So it lays out the content horizontally as well. So you can control the look and feel of the application using these columns as well if you want to control horizontal look and feel. And the other thing I do is you see these change indicators show the change since the last time I run the simulation. So what I'm doing there is holding those metrics in something that's called the session state. So that's a place where you can store data variables between Streamlit runs. So what happens is anytime you interact with a Streamlit app, it runs the app from top to bottom. So that means that if I didn't store those the figures from the last session away, I couldn't do that sort of delta functionality. So that's a nice technique as well. Okay. So that's that demo. Let's keep moving on. So that showed editable data frames, horizontal layout, and the session state concept. The next one is using a package that we use a lot for data validation called Pandera. Has anyone come across this? Really, really useful. So this scenario hits us a lot. We've built beautiful, big enterprise scale data pipelines, and then somewhere in that pipeline, off to the side, is a spreadsheet, and it's usually got some key reference data in it, like a list of product codes or office locations or something like that. And it's a key input to your analytics that you're doing with your data. And it doesn't change very often, but then when a human comes in and has to change that spreadsheet, they'll screw it up, right? And basically break the pipeline. So the solution that we tend to use here is we've got our enterprise pipeline here, medallion architecture. What we tend to do is put a Streamlit app in front of our pipeline wherever there's any human edited reference data like a spreadsheet. So the app I'm going to show you in this case is just the kind of data validation front end. So if I find it, there we go. Actually, I'll just demo it first. So data validation. So it's very simple, this one. No content really, just an instruction to drop a particular file into the app. So I've got pre-prepared spreadsheet here. So this one has got some errors in it. So I drop that in here. So it's loaded the data from the spreadsheet. There's only 26 rows, it's pretty small, but it's found errors and it's listing the errors here. We've got loaded 26 rows in total, but 8 of them have got errors. And if we expand the breakdown, let's just sort it by column. We can see the source column here has got 2. This is the rule it's breaking. So the source column should be one of these predetermined values. This is a spreadsheet that we use to collect what we call a digital asset register from clients when we're looking at their IT estate. So it's allowing them to define, is this application built, bought, or open source or whatever. But you can see this is broken. There's 4 issues with this column, and also again it's broken this rule where it's not nullable. And what we can do, because it's a small amount of data, we can actually display the source data. So there's the 24, 25. 26 rows, but they're they're indexed to 0, so it's 0 to 25. And you can see we've just highlighted the occasions where it's breaking the data validation rules. So there's the source column I was talking about. There's 4 instances of values that are not in the allowed range, and 1 empty cell here. So you can see here someone's clearly pasted their grocery shopping list into the spreadsheet by accident and then uploaded it. But they can see here what they've done wrong, and they can very quickly fix it. So if this is the end user, they'd say, okay, I've not broken the pipeline. I'll drag the fixed spreadsheet in here, and it's passed all the validation rules, and then they can click submit the data. So what it's doing here is hopefully, yeah, there we go. So it's connected to ADLS2 storage in the cloud and uploaded that file, and then that's in the bronze layer, ready to be processed for downstream processing. So if I go back, so that last stage was basically to submit the data onto the cloud to trigger downstream processing. So we use that a lot to protect our pipelines from end users. So here's some of the techniques that I've used in that app. So that uploader you get for free with Streamlit, st.uploader, and it creates a you can define what file types you're going to allow to upload in the first place. So in this case, I think I've narrowed it down just to XL files. And then the nice thing is, I'm not downloading the file, I'm streaming it straight into a data frame. So this creates an I/O stream that you can then stream straight into a Polars data frame in this case. And then this is where I use Pandera. So this data frame schema, you can see here, is a class that Pandera provide where you can define the schema. So basically the way that works is you define each column that you expect to see in your data set, the type, the data type, simple things like can it be nullable, does it have to be unique, and also you can add in rules, simple rules. So for example, the year column needs to be an integer and it has to be greater than or equal to 1900. So you can build up this sort of data contract for the data that's coming inbound into your organization. And then what Pandera does is it parses the data against these rules and it generates that detailed list of exceptions that you can then play back to the end user. Every failure of one of these rules will be listed out, and it gives them the feedback loop to then go away and fix that data, so it then passes and then you can use it. So you can see when it's successful, I use st.success. That's that little green bar that appears. So it even takes care of some of the formatting for you. When it fails, we use the st.warning banner. So it takes care of the styling of even status messages for you, which is quite nice. Okay, so that's really simple. It's pretty cool though. So we use the file uploader, which is an I/O stream straight into memory, which is quite nice. So you're not leaving any files lying around on a web server. We use the Pandera package. We define the schema, and then we validate against that schema the data frame that we've loaded from the Excel file, and that throws all the validation errors that we can then play back to the end user. And then we use the simple success and warning widgets to display all of that. And in production, what we do is we would deploy this app on the client's cloud infrastructure and use a managed identity for the app to allow it to connect to the lake storage and upload that file. That's what I use there to enable the app to push the data onto cloud infrastructure. Okay, I know I'm running quite over time here, David, but yeah, yeah. One question. Go for it. I can. Oh, here he comes.
So Pandera is used to validate the schema, and until I realised it was for the schema, I was going to ask, what's the difference between Pandera and Pydantic? But are there other alternatives to Pandera that can be used with Streamlit?
Yeah. The other popular one is Great Expectations. I don't know if you've heard of that, but that allows you to build up expectations of the data and rules and validate it and get itemized errors back.
Yeah.
Yeah.
Yeah, it's a good name for a library.
Yeah. So, but Great Expectations is pretty complicated to set up and manage. We just find Pandera's, because Pandera only deals with data frames, whereas Great Expectations, you can validate CSV files and Excel spreadsheets. It kind of goes down to the underlying formats as well.
Okay.
And it also does benchmarking and all other kinds of complex functionality. We just want, here's our data contract for this data frame. It might have come from a spreadsheet, but we'll load it into a data frame from the spreadsheet and then we'll just validate it. And then you get this itemized response back, which is works really well. We've got one client at the moment where we don't use actually a Streamlit app. They upload a spreadsheet to SharePoint. We have a pipeline that loads it from SharePoint onto Bronze. Then we validate it. And then it just generates an email, very similar to the Streamlit app. It just sends an email straight back to them. Within a couple of minutes, they get an email, and they'll fix the spreadsheet, run the pipeline again, and voila, it passes. Or they get another email showing them the things they've forgotten to fix.
And that's
works
using
really
Pandera.
well. Because what was happening before then is the pipeline was breaking. They were phoning us up. Oh, the pipeline's broken, and then you'd have to go in and look at all the error feedback, even from Pandera, and then write them an email. Right, you've dropped this column needs to be there, or this column has got some null values in it, you need to fix that, So it was just saving us half an hour every time they broke the upload process, and then that adds up to a lot of savings. And they think it's better for them because they get immediate response rather than waiting on us coming back, sifting through the logs to tell them what's gone wrong. They get this immediate response. It just creates that nice virtuous feedback loop for them. Works really well.
That's great. Thank you.
No worries.
I have a question as well, because I was in an unfortunate position to deal with similar issues, and it works for.
So
It works when you have one or two teams, but when you scale out, especially in like an enterprise, when you have multiple teams uploading data,
yeah.
versioning becomes a nightmare. Like, I'm not sure how you can manage that. And I guess this is kind of a bad pattern that's unfortunately everywhere. When if you use a database, it already has validation rules that prevents you from making those mistakes. But I also understand it's harder for users to deal with a database. So have you found a good middle ground to solve that problem and scale out instead of using Excel spreadsheets everywhere?
Yeah, I mean, the middle ground would be something like a SharePoint list or a Dataverse app, a Power App, where you can sort of build a schema and a kind of web front end over it. That tends to be the lightest touch way that we can enable business users to sort of manage this kind of data. I mean, don't get me wrong, most of the data is coming in from databases. It's just the odd spreadsheet off to the side often is lurking and you have to deal with it. So this is one of the techniques that we use. Yeah.
Any more questions? Right, cool.
All right, so we'll get this. I think this is my last demo. So couldn't do a set of demos without some AI or LLMs in the mix. So this is a fictional online barbecue business. I like barbecuing, so this is what I thought I'll base it around. So your website, people come on here and they buy barbecues, consumables, accessories, all the usual stuff to do with barbecuing, and they can leave, a bit like you see on Amazon, they can leave reviews, product reviews. So you're in a data team and you've done a lot of amazing work with structured data. You've got metrics for, purchases and which products are being bought and how many visits to the site. That's all great. But now the business want you to try and help them make sense of all of these free text reviews that have been generated. So this is the kind of app you can build off the back of your medallion architecture. So you've taken all of the data that's been collected from the web front end for your business. It's an e-commerce site, and you prepared the data. And from that, you're serving up these product reviews. And in this case, it's a JSON structure. Every review has got is a JSON entity, so it tells you, you know, a bit about the customer, because the customer has logged in and left the review for a purchase they've made, so you know where they're from, a bit of data about them, you know the product they left the review for, and then you've got a star rating and then the actual free text review. So that's what's coming in as product reviews. The first problem you've got is you're a global business, so you've got reviews in Spanish and French. So the first thing you need to do is put them through a translation model. Then you want to be able to try and classify the reviews. So were they talking about build quality? Were they talking about ease of use? Were they talking about delivery? So you use a classification technique to extract those kind of tags. And then finally, you need to try and reason with the semantics of the actual plain text review they've written. This product's amazing, I love it, versus this product sucks, I'm never shopping here again. How do you deal with that? Well, the technique for that is to embed the text and then store those vector embeddings. So an embedding is a vector. It's a multi-dimensional vector that captures the semantics, the meaning of a sentence or a paragraph or a block of text. So that vector can then be stored in this case, in Azure, in AI search, which will store the structured data, the review text, which has been translated to English, and the embedding. So that's the kind of setup bit that I've done pre-Streamlit. So I've got this knowledge store, just see it as a knowledge store, all of this stuff in a knowledge store. And then what I can do is the user can then ask a question. The embedding, what happens here is we've embedded the reviews, but what we can now do is embed the question and then search the knowledge store for reviews that are close to the kind of question that's been asked. So if someone's asking about the paint quality of the product or the ability to cook food perfectly, then we'll find reviews that have talked about well-cooked food, for example, through this search. So that retrieves the knowledge. So then what we do is we give the LLM the original question and all of the relevant reviews from the knowledge store in a single prompt. We say, here's the question. They've asked about reviews related to cooking food nicely. Here's a whole bunch of reviews that talk about that. Condense that into a nice answer. Okay, so that's what I'm going to show you in action here, if it works. So product reviews. So here's my product review analyzer. And what I've got here is I can facet the search. So let's just say I'm just interested in grills. I can just narrow my search, my question down to grills, and I can ask what the main build quality issues that users found. Try that. So again, it's a long-running operation, so we're just telling the user what it's doing. So it's gone away, retrieved the knowledge, and then sent that all off in a prompt to the LLM, and you can see it's come back with this response. So there's a bit of engineering behind the scenes, because what we've got is citations. So we've asked it to include citations to the knowledge that it's used to produce this answer. So the top thing here is about items that have arrived with damaged or with defects. It's summarized these 5 reviews. So hopefully if you click on one of these, this is not very pretty, I have to warn you. Oh no. Let's try another one. Oh, there we go. So if I zoom in here, so this is a real review. You can see it's come from someone in the United Kingdom. They were reviewing grills. This is the product they were reviewing. They only gave it a rating of 1. And you can see somewhere in here, there was something about build quality that came back. So that's why it's citing that response. So what you create here is an LLM-driven analytics over all of that unstructured data, but it's backed up with the citations so that it helps people build confidence that the LLM's providing useful and relevant responses. So let's have a look at the code and see the key things that I've done there to make this work. So the first thing is the little floating chat widget at the bottom here. You can see what question would you like to ask is st.chat input. So that allows you to pin that chat input input field to the bottom of the web browser, and when you fill in a question, it returns this prompt object. And then what it does is immediately displays that prompt in the chat message stream. So you can see I asked this question, and it's therefore inserted that question into the stream. And it's flagged it, as you can see, the role is user, so it's put this nice little user icon on it. And then it stores that. So I'm using session state again, the same technique I used before, but I've got a message history list, and it appends the role and the prompt that I've just inputted into that message history. And it needs to do that because every time I interact with the app, if I ask another question, what did users love? You can see it's building up that history. And because Streamlit, if I didn't retain that history, the screen would just go blank, basically. It needs to replay all the questions and all the answers every time I interact with the application. So that's the technique for sort of building up that message history. And then we send the prompt off to the large language model. We get the response, and you can see immediately, because that's a long-running operation, I'm using a sort of spinner to keep the user informed that something's happening. And then you can see I display the response, but this time I'm marking it as an assistant message, having converted the response to an HTML-friendly format, so you can see the hyperlinks to the citations are available. And then again, I store that message away in the history. So what happens is this script runs top to bottom every time I ask a new question. It runs top to bottom, but as part of that, right at the top, the first thing it does is it replays any history I've built up from previous iterations of the application. So something with Streamlit you have to get your head around is this fact that any time you change the state of the application as a user or through a callback, it will run the whole script. So you've got to try and manage that by either storing stuff away that you don't want to lose when it renders again, or by hiding things, or just stopping the script, or other techniques. There we go. So yeah, so that's chat input, message. So chat input is the thing that's pinned to the bottom. The messages are the stream that you insert. Session states used to hold the message history, and then longer running operations, as you do get with chat interfaces, are managed as well. So the key thing now is, has my deployment, that deployment I was doing earlier, has it worked? I'm going to test it. I don't know if you want to test it. It's got that annoying 5-second delay in it. If you click there, you should get my Titanic app. Right, okay, I've really run over, I'm sorry, David. But so Streamlit is amazing. It brings together application development discipline and data science and analytics disciplines closer and closer together. And that's why I certainly like working with it. And in the current environment where you're working in a data team trying to deliver solutions to end users, anything that can speed up that inner dev loop, allowing you to loop round, deliver something to end users, get their feedback, iterate again and again, is obviously to be welcomed. But the other interesting thing about Streamlit is it opens up new capabilities. You can deliver, the examples I've shown you tonight are just some small examples of things that you can deliver, capabilities you can deliver that are kind of back office, data science capabilities or sophisticated models, you can actually put those into the hands of end users using technologies like Streamlit. It is kind of fixed in the way it works in terms of the look and feel, and you know, you will, if you want to really control the fine-grained look and feel of it and other behaviors, you're probably going to want to switch into sort of custom web app development. But I kind of like the fact that it, you know, you don't have to think about some of that stuff. It looks pretty good. It's a nice look and feel to me. It allows you to get something out there. You can sort of brand it a little bit, but it allows you to get solutions out quickly. And then maybe at some point you pivot away from Streamlit if it needs to go full custom web app development. But it's great for getting rapid prototypes out there. So I've talked about a huge amount of stuff. I'm running out of voice here. Everything I've talked about is in our blogs. So Streamlit and all the other stuff is all on our blog. So if you want to know more about Streamlit or Duck Lake or Polars or anything else I've touched on tonight, please go and visit our blogs. We love to share the work that we do and ideas that we generate. And don't go to that link. That was from my last talk. But I've got some limited edition stickers here. If you would like one, please come in. Please come and see me. And that's it. Thanks very much.
Cool. That's officially the longest talk we've ever had.
Sorry.
No, you're fine. Does anyone get any questions? We'll wrap it up. No, got one question. Cool. There is one question from online as well.
All right, brilliant.
Cool talk. Obviously, Streamlit's primarily. So I've used Streamlit before, and it's neat. I like it. Obviously, you primarily interact with it via the web browser. But have you had any experience like trying to just kind of sneak it into something like Power BI or MS Teams so that users basically don't know they're interacting with a website? Because I like clicking through lots of links as much as the next guy, but if we can just kind of make it all seamless, then that's just going to make it so much more accessible.
Yeah. That's a great idea. No, we haven't done that. We tend to just deploy it as a standalone web app that people go to. I'm wondering whether you could probably embed a website in Teams. I don't know. But what we can certainly do is the authentication to get into Streamlit. If you're using like Entra, all of that can be seamless. So you're not asking people to sort of authenticate separately. So I think you could probably, I've not tried it, but you could probably embed it certainly in Teams, but no, not Power BI, not tried that. Power BI is embeddable. You can embed, you can do the reverse. You can embed a Power BI report inside a website as an iframe. That's dead easy to do, but I think the other way around's not possible, unfortunately.
Any other questions from now? Okay, so there's one from online, and it says, I'm not sure how to pronounce this. I'm fairly sure it's Tagitique,
Okay.
which is, it seems to be some sort of product that, so it's, it'd be interesting to see where you think Tagitique sits in this reporting tool or data app. Also your thoughts if you've come across it.
I haven't, no,
I've never heard of that
I haven't
either.
heard of that. Oh,
Yeah.
That's a shame. Okay, I'll have to research that.
Yeah, I think I need to look that up as well. I think I got that right. Probably not.
Okay.
No other questions? No? Okay, well, I think we'll wrap up there then. Oh, it's a finance one.
Oh.
Okay, well, I maybe need to look that one up.
Okay. Right.
Okay, perfect. All right, well, thanks very much for that.
Cheers.
We'll end the stream there.